16-bit CPU. 16-bit CPU. In that case, this EX register is divided into two halves. One is AX, okay, and this is the other part, okay. So in 16-bit, we are only worried about this register. So the name of the register is called as AX, okay, in 16-bit, okay. And when we are, let's say, having a system which is 32-bit, the name of that same register, it changes to EX. E is the full form of E is extended AX, okay. Similarly, when we are dealing with 8-bit CPU, the same AX is divided into two parts, okay. The one is AL, A lower, and one is AH, A higher, okay. And this, both of them are of 8 bits, okay. So this is all about like what the space of that memory, what the space of that register value, okay. And the thing is that like this is of 8 bits, this is of 8 bit, this 16-bit, and then compromising this both the things twice, it becomes 32-bit, and that things like go on for 64-bit, okay. So in this is like how the memory is basically kind of sorted out internally. Like you can also like even let's say you have 32-bit CPU, you have a 32-bit CPU, you can store the value directly into the AL, saying that I want to store AL equal to 5, you can do that. Because what will happen in that case, the 5 will be stored somewhere like over here, okay, directly into the AL register. So that is something also you can do. You can also specify EAX equal to 5. So the value of 5 will be stored in this register. You can also specify AL equal to 5 in 32-bit CPU. The value will be stored in this part of section, okay. So this is how the register is kind of made up. So before proceeding further, I understand like this is very, very complex to understand. I will kind of again kind of reiterate what thing we are doing. So overall thing is that CPU is made of control unit, execution unit, register, and flag. And thing is that then there are memory concepts that we have seen. And now we are all looking at the register value at a much more in-depth look. And then in the register value, we are telling that, okay, there are like different kinds of register, like general purpose register, segment register, EIP register, control register. And now we are looking in much more depth what is EX register, okay, how the EX register is kind of set up in the computer, okay. And what we see is that the EX register is all about, let's say, it's comprised of EX, is then AX, AH, and AL, okay. So this is all about like how the memory is kind of divided in at a core in the Windows operating system or Linux operating system or any kind of computer, okay. So guys, if this is really complex, I understand. If you guys have any questions till this point, let me know, or else I will assume that you guys are able to understand everything, okay. So let me proceed further. So we have kind of looked at the CPU in a much deeper fashion, okay. And today for the exploratory, you don't have to worry much about the, like, let's say the IO devices and all. Memory, definitely we'll look at the memory. That's where the whole game is, like how we store the payload in the memory, that's so that it can kind of go and be executed by the CPU. So we'll look at that. And let me see something else. And the memory part, the one that I'm telling over here, the memory part over here, it's actually made of different, again, it is made of different components, okay. So think is that, let's say now let's have a little bit look how the thing is that how the memory is allocated. We have learned about the CPU at a very deep level, how it is made of, and now we'll look at the little bit about the memory, okay. So now thing is that, let's say we in our hard drive, let's say what we have is let's say we have a software called a malware software or any kind of software like a.exe, for an example, a.exe. Okay, so what will happen is that a.exe, when it will be kind of loaded up from the hard drive to the RAM memory during the execution, this is how the a.exe, when it will be kind of loaded up in the RAM memory, okay, from the hard drive, this is how the sections will be there. So this is the whole data, let's say, the whole data of a.exe loaded up in the RAM memory, and that part will be divided into 6 chunks. So the first chunk will be the stack memory, the next chunk will be the unused memory, heap, BSS, data, and text. Okay, so whenever, let's say, any kind of software is loaded up from the hard drive to the RAM memory, so and let's say it has been loaded somewhere, like here, it has been loaded in the RAM memory. So this part is comprising of 6 different kind of sections for that system, for that software. Okay, only for that software. And this will be same for each kind of software that is loaded up in the RAM memory. Okay, so in the RAM memory, what will happen is that it will be made of a stack, it will be made of unused memory, heap, BSS, and all. So thing is that, what about the text? The text will be the actual, it will store the actual code of abc.exe. So once this a.exe is loaded up in the RAM memory, the code of that a.exe, what things that needs to be executed of that code, of that software, will be residing in the .text section. So the full code of that software will be residing in the .text section. Just think of that, okay? And just keep that in mind. Now, then there is, let's say during the execution of this software, let's say there are different kind of values like a equal to 10, a equal to 10, b equal to 20. Let's say the code is something like this, okay, b equal to 20, and c equal to, let's say, a plus b. So what I mean to say is that, let's say this is the code that is of a.exe. So the code of a.exe is only this 3 line. Let's suppose that. So this will be stored in textual format in this .text section of that memory, okay, of that a.exe, in the .text section, okay, the whole code. Now, when this line will be executed, a equal to 10, so data will be something over here. When it will be like loaded up in the RAM memory, the a equal to 10, that initialized data will come up, and that variables will be stored in the RAM memory over here, like a equal to 10, okay, or b equal to 20. So those initialized data will be coming over here, okay. Similarly, uninitialized data like c equal to a plus b. So let's say the c value will be 0, will be for now, okay. So it will be coming up in the uninitialized data, okay. And when the execution will happen, that's where the c equal to 0 will be coming out from here, and it will be kind of coming in here, where the value of the here will be c equal to 30, okay. So this is how the things look like. And then for each kind of software, they will have their own stack memory, they will have their own heap memory, okay. Sections are named as stack and heap, and there is certain section of unused memory. And what the stack is all about, stack is all about kind of executing the code. Let's say this code has different kind of functions, so those all data, the functions data, let's say this a.exe also has a function like for example, let's say add, okay, add a comma b, and we say c equal to a plus b, okay, and then let's say we return c. So this is the code. This is the code that is something kind of let's say this is a function, for an example. So that function, how the execution will happen, this function, this all thing will be dealt in the stack memory. How this function will be called, and how this function execution will happen. This all thing will be happening in the stack memory. Okay. So that's the thing. And now the thing is that then there is certain thing